Intro start kaledu. Hello friends, my name is Sailoy. I am studying in B.Tech Vellore Institute of Technology. Few days back, I have read an article in a magazine called IEEE Signal Processing Magazine. The name of the article was Autonomous Driving. We have come across this name in a different manner: self-driving vehicles or self-driving car. This technology was first coming to market by the company called Tesla. We all know this company. This company is famous for its electronic cars. This company also bought the technology of self-driving cars. We are, we got a doubt. How a car can also drive on its own? Yes, it can drive on its own with the help of an AI. Today, I am going to cover in this session about what I have read in that magazine. Let's get started. First, let me share my screen. Autonomous driving. So, in this session, we are going to cover brief about the article, what is an AI, how this system function, and a short video for a better understanding the process of involved in this self-driving cars. Brief about the article. This article was published in IEEE Signal Processing Magazine in volume 37, issued on July 2020. This article covers about how the advancement of AI transform the future transport facility. So let's get started into the matter. As for everything starts with three questions: why, how, and what. Let's come to why. Why do we need this technology? We need this technology since most of the teenagers who are driving the cars are generally involved in using in smartphones or in any other activities like talking with the other passengers, etc. etc. According to a survey, most of the vehicle accidents caused when the driver was involved in any other activity or else using a smartphone or else in talking with some other persons. So people people wanted to bring a solution for this problem. The solution was self-driving cars. Let's come how. With the help of sensors, the sensors process the information and gives the input to the control system. The control system later processes that information and gives an output to the vehicle, such as throttling the acceleration, rotating the steering wheel, applying brakes, owning the indicators, etc. etc. What? The use of this technology minimize the accidents and so cost and the time can be saved. The person who is in the car or a passenger can easily go to the initial location to their destination location in a short period of time since everything is predefined. Now let's come to what is an AI. How does it works? Artificial intelligence, or simply called as an AI. AI is simply but nothing but an virtual brain which has capability of thinking on its own and performing the task on its own. Like as we are human beings, we take input from our eyes, nose, and ears. With that information, which we have collected from eyes, nose and ears. The brain processes that information, and with the help of the stimulus, we perform actions like lifting our hand, moving with our legs, etc., like speaking and daily activities. In other words, we can simply call an AI as a third person who understands only binary data information and reacts according to it. Unlike our human beings, we react with our senses and perform the task. Where this AI only understand the languages such as computer languages and perform its task. Now let's see what we work on AI. Sensors, binary language 1 to zeros, bits like size of 1, 8, 16, 32, 64, some restrictions. Like this, we get this doesn't make any sense. Like now let's me come through this. Sensors. Sensors means nothing but like ultrasound sensors, lighting sensors, moisture sensor, etc. Binary languages. Generally, we know the programs like C, Java, Python. These are computer languages, but the computer won't understand the language. Initially, we give the input in the computer language, but the computer transform that language into the binary languages, which means ones and zeros. Computer only understand this language, not the language which gives. This language later stores in the memory location with amount we gives the information. It divides the information into its own size like packs. 8 bits, 16 bit, 32 bit, 64 bit. These bits are the size of the memory locations. So the amount of information which we give is stored in the memory location size which is suitable for its convenience. Unlike we human beings, we have some rules. Unlike we will also give some restrictions to the AI so that it cannot cross the limits and perform on its own. No, let's come to the driving part of an autonomous cars. How this can all happen? The integration of advanced sensing, signal processing, artificial intelligence, and control technologies into vehicles is enabling intelligent automated vehicles that can navigate autonomously in various environments. Which means the advancement in the technologies like AI and signal processing and control technologies means nothing but the sensors, the software, etc. helps the car to sense the environment and behave according to it. To have success in this autonomous driving cars or self-driving car, we need some tech. Tech is nothing but an technology in a short manner. The tech we need for the success of this self-driving cars are first camera. You may get in a doubt that how camera can help. I will come to this point later. Ultrasound system, global navigation satellite system, or GPS, LiDAR. We come across these three items: camera, ultrasound system, GPS. But this LiDAR part is new for us. I will explain the next slide what is an LiDAR. Now let's come to the point. With the help of camera, the car sees the 360 degrees surrounding so that it can take input of the surroundings and perform according to it. With the help of ultrasound sensor, the car gets the distance between the obstacle in front of it, uh, so that it can do some calculations and give the outputs for throttling the acceleration, braking and steering the wheels. With the help of GPS, a global navigation satellite system, the car knows the exact location where it is and can calculate how far should we go or to reach the destination location. Now, LiDAR. Now we come across the part LiDAR. LiDAR is nothing but a small device which sends an light signals or else we can call it as an signals in a small bits, like small bits are some parts, so that the signals can act interact with the obstacle in front of it and bounces back, and the sensors with collect those signals and do some digital image or 3D image. With the image it can see the what is the object or an obstacle in front of it. How the system functions. First, with the help of using LiDAR and ultrasound technology, the vehicle detects the distance between the obstacle and forms a 3D image as a result, which helps the system to form a pathway to reach the destination location. Whereas using the camera helps to visualize the surroundings and help to find more precise with the help of LiDAR image. With the help of GPS, the vehicle knows where the exact location it is in and how much far distance it need to cover to reach the location. Now, this is a small block diagram, and the small basic function with this block diagram we can see how the system functions. The visual processing and radar processing and laser processing and ultrasound processing. These four are the inputs. With these inputs, the sensor fusion AI platform collects the information. These two are softwares. This is GPS. With this info and with the help of GPS, it knows the terrain or the surface area, so that it can react according to it. This GPS is connected to the digital maps, or else we can call it as in Google Maps. The digital maps gives the terrain location and the places of it, so that the routes can be pre-guessed by the AI and the traffic can be analyzed. The visual processing is nothing but the 3D images across it or else the objects across it. With the help of radar, radar collects the signal which bounces back when the LiDAR sends them. Ultrasound is used so that the distance between the object and the vehicle can be calculated and act according to it. And this final output is vehicle controlling. So let me show a short video how this functions.
It's late, pitch dark, and a self-driving car winds down a narrow country road. Suddenly, 3 hazards appear at the same time. What happens next? Before it can navigate this onslaught of obstacles, the car has to detect them. gleaning enough information about their size, shape, and position so that its control algorithms can plot the safest course. With no human at the wheel, the car needs smart eyes, sensors that'll resolve these details, no matter the environment, weather, or how dark it is, all in a split second. That's a tall order, but there's a solution that partners two things: a special kind of laser-based probe called LiDAR, and a miniature version of the communications technology that keeps the internet humming, called integrated photonics. To understand LiDAR, it helps to start with a related technology, radar. In aviation, radar antennas launch pulses of radio or microwaves at planes to learn their locations by timing how long the beams take to bounce back. That's a limited way of seeing, though, because the large beam size can't visualize fine details. In contrast, a self-driving car's LiDAR system, which stands for light detection and ranging, uses a narrow, invisible infrared laser. It can image features as small as the button on a pedestrian's shirt across the street. But how do we determine the shape or depth of these features? LiDAR fires a train of super short laser pulses to give depth resolution. Take the moose on the country road. As the car drives by, one LiDAR pulse scatters off the base of its antlers, while the next may travel to the tip of one antler before bouncing back. Measuring how much longer the second pulse takes to return provides data about the antler's shape. With a lot of short pulses, a LiDAR system quickly renders a detailed profile. The most obvious way to create a pulse of light is to switch a laser on and off. But this makes a laser unstable and affects the precise timing of its pulses, which limits depth resolution. Better to leave it on and use something else to periodically block the light reliably and rapidly. That's where integrated photonics come in. The digital data of the internet is carried by precision-timed pulses of light, some as short as 100 picoseconds. One way to create these pulses is with a Mach-Zehnder modulator. This device takes advantage of a particular wave property called interference. Imagine dropping pebbles into a pond. As the ripples spread and overlap, a pattern forms. In some places, wave peaks add up to become very large. In other places, they completely cancel out. The Mach-Zehnder modulator does something similar. It splits waves of light along two parallel arms and eventually rejoins them. If the light is slowed down and delayed in one arm, the waves recombine out of sync and cancel, blocking the light. By toggling this delay in one arm, the modulator acts like an on-off switch, emitting pulses of light. A light pulse lasting 100 picoseconds leads to a depth resolution of a few centimeters, but tomorrow's cars will need to see better than that. By pairing the modulator with a super-sensitive, fast-acting light detector, the resolution can be refined to a millimeter. That's more than 100 times better than what we can make out with 20/20 vision from across a street. The first generation of automobile LiDAR has relied on complex spinning assemblies that scan from rooftops or hoods. With integrated photonics, modulators and detectors are being shrunk to less than 1/10 of a millimeter and packed into tiny chips that'll one day fit inside a car's lights. These chips will also include a clever variation on the modulator to help do away with moving parts and scan at rapid speeds. By slowing the light in a modulator arm only a tiny bit, this additional device will act more like a dimmer than an on-off switch. If an array of many such arms, each with a tiny controlled delay, is stacked in parallel, something novel can be designed: a steerable laser beam. From their new vantage, these smart eyes will probe and see more thoroughly than anything nature could have imagined, and help navigate any number of obstacles, all without anyone breaking a sweat, except for maybe one disoriented moose. What happens when...
Now, let's come to the main part. Now we have seen the video and get some clarity how the self-driving cars function. Since in this present generation, only the the starting of the self-driving cars getting started. And when the advancement comes, we can minimize the LiDAR into small device so that the space of the car device occupying in the car will be get reduced and getting more advantage. Let's come to the advantages and disadvantages. With the help of this technology, we can minimize the traffic accidents occur in our daily life. Since this technology is linked to the GPS, and nowadays in GPS, even the traffic can be shown. So the car takes the less traffic route and we, uh, we can easily reaches the destination in a short period of time. With the help of this technology, many people are getting involved in this AI and developing more and more. With the help of this technology, we can save our time, and since the car is automatically driven by this technology, we can use that time in our actions. So we we are getting covering our work and even doing more actions. That comes to disadvantages. This technology is too expensive, and maybe in future this technology can be get cheaper, since this technology is just in a mature stage. This technology was only given in few cars like in Tesla, BMW, and in Mercedes Lightning version. And this technology needs to get updated day to day, as like our cell phones, laptop, any other electrical devices. Thank you.